You got, yes, it's not the index because an index would be a half if it was the index was 2, but the highest exponent is 2, exactly. So basically a quadratic equation is an equation where the biggest index, not the index, the biggest exponent is 2. If the exponent is 4 or the exponent is 3 or the exponent is 1, we are not able to use the quadratic formula. The quadratic formula only works on quadratic equations. And how do we identify a quadratic equation? It's an equation where the biggest exponent is 2. So I asked the other class, I'll ask you, do you guys want to see, well, if you remember from Algebra 1, the quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. There was a song. You're right. Who wants to sing the song? Yeah.
He was in my algebra.
Okay. That was not the song I've heard before. Okay. It's all right. Thanks for singing. All right. So I asked the other class, do you guys want to see where this was derived from? Yeah? Okay. So I can show you where it was derived from. You don't have to write it down because you don't need to know. So we know a quadratic formula looks something like ax squared plus bx plus c equals 0. Do we agree? All right. And when we're using the quadratic formula, we're solving for x. So what's going to happen here is I'm going to solve for x by completing the square. I'm going to move whatever my constant would be to the other side, which is c. So we're going to have ax squared plus bx equals negative c. You guys don't have to write this down. And then I don't want to complete the square with a leading coefficient. So what I'm going to do is I'm going to divide out the a under everything. So that leaves us with x squared plus b over ax equals negative c over a. Now we will complete the square. So we go to the x coefficient, which is b over a. And we go to that x coefficient and we take half of it. So I'm taking b over a and multiplying it by a half, where we get b over 2a. After I take half of the x coefficient, what do I have to do to it? Square it. So we end up with b squared over 4a squared. So I'm going to add a b squared over 4a squared to the left side and to the right side. Now we're going to factor the left side. And if you guys remember when we were completing the square and we were factoring, this ended up being a perfect square trinomial. So to factor it, we're just going to take x plus the square root of that last term. So we're going to have x plus b over 2a quantity squared equals, now in order to add these, don't I need a common denominator? So I'm going to multiply top and bottom by a 4a to create that common denominator. So I'm going to have b squared over 4a squared minus 4ac over 4a squared. Everybody okay so far? Okay, so now I'm going to add the right side. So we have x plus b over 2a quantity squared equals b squared minus 4ac all over 4a squared. Now we solve. To undo a square, we're going to take the square root. And now remember, when we're solving and we have to square root, we have to account for the positive and negative value. So I have plus minus the square root of b squared minus 4ac over the square root of 4a squared, which is just 2a. My end game is to solve for x, so I need to subtract that b over 2a over. So I end up with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And isn't that the quadratic formula? All right, so that's where it comes from. Now let's see how we're going to apply it. You don't need to know where it comes from, but you do need to apply it correctly. So I want to solve by using the quadratic formula. So we'll start off simple. Let's say I have 3x squared plus 5x minus 4 equals 0. All right. Before we use the quadratic formula, a couple of things we want to make sure about the equation. We want to make sure it's in standard form, meaning I need everything on one side, the other side equal to 0. I need my exponents in descending order, x squared x constant, if it's the bill. So essentially, I'm just saying we need to make it look like ax squared plus bx plus c equals 0. Then what we're going to do is we're going to identify our a, our b, and our c. So our a is the leading coefficient, which is 3. Our b is the coefficient of the x term, which is a positive 5. And our c is our constant, which will be a negative 4. You include the signs with it. Anybody confused with how I got A, B, or C? So once you identify those, it's just an easy plug-in into the formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now we just plug in. So x will equal negative b. Well, my b is a positive 5, so the opposite of positive 5 is negative 5. And then we're going to square 5 and then subtract 4 times 3 times a negative 4 all over 2 times 3. I'll let you all catch up. So x is equal to negative 5 plus or minus the square root of 25 minus, or a negative 4 times a negative 4 is a positive 16. Positive 16 times 3 is a positive 48. All over 6. So we keep going. X is equal to negative 5 plus or minus the square root of 73 all over 6. Can I simplify the root of 73? No. If I could, would I have to? Yes. So this is my answer. How many answers does this have? 2. We have negative 5 plus the square root of 73 over 6. That's one answer. And then we have negative 5 minus the root of 73 over 6. That's my second answer. Was I supposed to have 2 answers? Yeah. How did we know that we were supposed to have 2 answers? You got it. So the biggest exponent we have tells us how many answers we're supposed to have. So my biggest exponent, the degree of the polynomial, is our biggest exponent. So our degree of this polynomial is 2, which tells us we should have 2 answers for x. Do we all agree this is a quadratic equation? What does a quadratic equation look like when we graph it? We talked about this with the word problems. It's a parabola, right? And what do these x numbers represent, our x values when we solve? Does anybody know what they represent? Helen? No. You got it. These are our x-intercepts. These are the points where we're crossing our x-axis. So this parabola is crossing our x-axis in 2 places, as most do. Sometimes we don't, and we'll talk about what happens there later on in the class. All right, next problem. 3/2 x squared plus 1/2 x equals 3. Is this in a good format to plug in right now? No. First thing we want to do is make sure it's equal to 0. So I'm going to have 3/2 x squared plus 1/2 x minus 3 equals 0. And now I can plug in using fractions, but I hate working with fractions. Why in this scenario am I allowed to eliminate the denominator? Does anybody know? Why am I allowed to eliminate the denominator? Omesh? Because it's an equation, because I have an equal sign and I have something after that equal sign. Had this just been an expression, had there not been an equal sign, had there not been something after that equal sign, can I eliminate the denominator? Never. But because it is an equation, I can. So I'm going to go ahead and do that because I think it makes everything so much easier. So I'm going to multiply every single term by 2. These 2's cancel, these 2's cancel. So I'm left with x squared plus x minus 6 equals 0. Oh, 3x squared. Good catch. Thank you. What's the a here? 3. What's b? 1. Even though there's no number there, there is a 1 there. That's a 1x. And our c is negative 6. So now we're just going to plug right into our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What's up? Yes. So x is equal to negative b. Well, my b is 1. Negative b will be negative 1. Plus or minus the square root of 1 minus 4 times 3 times negative 6. All over 2 times 3. So x equals negative 1 plus or minus the square root of 1, and then negative 4 times a negative 6 is a positive 24, plus 3 gives us a positive, times 3 gives us a positive 72. All over 6. So x equals negative 1 plus or minus the square root of 73 over 6. I promise it's not always going to be the root of 73. That's a great question. So for me, quadratic is last resort. I would always go with factoring first if possible. So if you can factor, that will always be the quickest way. I would generally prefer completing the square over the quadratic. For me, quadratic's last resort. A lot of students, right when they learn quadratic, they use it every time, and then they just end up with numbers that are too big and radicals that are too big that can be simplified, but then they don't simplify it and just end up losing points. On the test, I will tell you, solve this using the quadratic, solve this by completing the square, and then other problems, I'll let you do whatever you want. Okay, next one. Root 6 x squared minus 4x, equals 4x plus 2 root 6. Is this in a good format? No, I need to set it equal to 0. So the first thing I'm going to do is subtract over. So I have root 6 x squared minus 4x minus 2 root 6 is equal to 0. So I'm okay with radicals. A lot of people don't like radicals. For me, if I can get rid of a fraction, I will. In this scenario, there is no getting rid of a radical. Even if I multiply every single term by root 6, I would cancel out these root 6's, right? But wouldn't I just create another root 6 in the middle? So there's no point in even trying to not work with the radical here. We're just going to work with it. It's not that bad to work with. So we have our a is root 6, our b is negative 4, and our c is a negative 2 root 6. And we're just going to plug right into x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, do we all agree our b is -4? So negative b is the opposite of -4. What's the opposite of -4? +4. So now we have +4 plus or minus. Now be very careful here. I'm squaring that whole -4. So the whole -4 needs to be in parentheses raised to that second power. -4 times √6 times a -2 √6. All over 2 times √6. Are we allowed to have a radical in the denominator? No, I'm going to take care of that at the end. That's the least of my concerns right now. More importantly for me, I want to simplify what's underneath that radical at the moment. So we're going to have x is equal to 4 plus or minus -4 squared is 16. And then -4 √6 times a -2 √6 is going to give us a +8 times 6, which is a +48. All over 2 √6. So I'm still trying to simplify what's inside that radical. So I have 4 plus or minus the root of 64 all over 2 √6. But what is the square root of 64? 8, right? The square root of 64 is 8. So we're going to have x is equal to 4 plus or minus 8 over 2 √6. This is not my right answer for so many reasons. This is not my answer because I still have a radical in the denominator. This is also not my answer because can I add and subtract 4 and 8? So I'm going to start by making this into two different equations. I'm going to have x is equal to 4 plus 8 over 2 √6. And I'm also going to have x is equal to 4 minus 8 over 2 √6. And I'm going to sort of solve each of these separately. So we have x is equal to 12 over 2 √6. 2 goes into 12 6 times. So now I'm going to have x is equal to 6 over √6. What can I do now, or what should I do now at this point? We have to rationalize, exactly. I have to rationalize, so I multiply top and bottom by √6. So we're going to have x is equal to 6 √6 over 6. What happens with the 6's? Cancel. So we just get x equals √6 as one answer. Now we do the same thing on the other side. So x will equal -4 over 2 √6. I can simplify and I'll get x is equal to -2 over √6. We're going to rationalize. So x is equal to -2 √6 over 6. Simplify once again. So we get x is equal to -√6 over 3. What do these numbers represent? The x-intercepts, where my parabola is crossing the x-axis. All right, last one before we move on to something different. What number was this? 3. Was anybody still copying this? No, we're good. Okay, 4. Y plus 3 over 2y minus 1 equals 2y plus 3 over y plus 5. I need to solve for y. What should I do? Cross multiply, you got it. We're going to cross multiply. So I'm going to get 2y minus 1 times the quantity of 2y plus 3 equals y plus 3 times the quantity of y plus 5. I have to FOIL. So I start FOILing, so I get 4y squared plus 6y minus 2y minus 3. And on the other side, y squared plus 5y plus 3y plus 15. Combine our like terms, we get 4y squared plus 4y minus 3 equals y squared plus 8y plus 15. So I want to solve by using the quadratic formula. What should I do now? So we cross multiplied, we FOILed everything out. What should I do now? Well, in order to use the quadratic formula, what does it have to equal? 0. So I need to set it equal to 0. So I'm going to subtract the y squared, the 8y, and the 15. So the right side all cancels to 0. The left side, we get 3y squared minus 4y minus 18 is equal to 0. Can I now use the quadratic formula? Absolutely. My a is 3, our b is negative 4, and our c is negative 18. And we have y is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So y is equal to positive 4, right? Because we want the opposite of negative 4, plus or minus the square root of negative 4 squared minus 4 times 3 times negative 18 all over 2 times 3. We're going to be having a bigger number underneath that radical. So we have y is equal to 4 plus or minus 16 plus 216 all over 6. So we have 232 all over 6. Should I try to simplify the root of 232? It's an even number. You should at least try. And when we have 232, 4 actually goes into it. So it's 4 times 58, and then 4 becomes 2 and 2. No point in breaking up the 58, because when I break up the 58, it becomes 2 and 29. Any pairs I can get from that? No. So we just end up with 2 root 58. So now we're going to have y is equal to 4 plus or minus 2 root 58 all over 6. How come this is not my final answer after all this hard work? Stephen? Yeah, I can pull out a GCF of 2. So I'm going to do that. Pull out a GCF of 2. I get 2 plus or minus the root of 58 all over 6. And then 2 goes into 6 3 times. So we have y is equal to 2 plus or minus the root of 58 all over 3.
Once you got everything to equal to 0, could you also have completed the square?
If it were up to you, yes. But my directions was said to solve using the quadratic formula. But yeah, that would have worked if it was up to the person solving it. All right, so that's the end of quadratic formula. Now what we're going to do is we're going to talk about something called the discriminant. Yeah? Okay, so the discriminant determines the nature of the solutions to a quadratic equation. Again, how do I identify a quadratic equation? The biggest exponent has to be 2. So this discriminant only works on quadratic equations. And what I mean when it says it determines the nature of the solution, so we know in a quadratic equation we should have 2 solutions because our biggest exponent is 2, right? So it tells us not the exact solutions, it tells us what kinds of numbers our solutions are going to be. Are they going to be real numbers? Are they going to be imaginary numbers? We actually have 3 different scenarios, or maybe 4 different scenarios, depending how you look at it. So that's what we're going to go through now. So the discriminant is actually the formula. B squared minus 4AC. And we have different scenarios. So the first scenario is if B squared minus 4AC is greater than 0, then we're going to have 2 rational roots. Oh, not rational, sorry, real number. I lied. 2 real number roots. Okay, well, real numbers have 2 separate categories. Does anybody know what, under the real numbers category, what are the 2 subcategories that fall under real numbers, Justin? Rational and irrational. And so that's going to come into play too. So if we go to the rational, or we can go to the irrational. So if B squared minus 4AC is greater than 0 and is a perfect square, the equation will have 2 rational roots. And what do I mean when I say is a perfect square? Can somebody give me an example of a perfect square? Lucas? 9. 9 is a perfect square. Is 36 a perfect square? Yeah. Is 25 a perfect square? Yeah. What is a perfect square? Stephen? Yeah, it's the product of a number times itself is a perfect square, right? So if our discriminant is bigger than 0, but is also a perfect square, not only will we have 2 real number roots, but those real numbers will be rational numbers. And so if B squared, let's change our color here, go light blue. If B squared minus 4AC is greater than 0, but not a perfect square, the equation will have 2 irrational roots. Like the square root of 2, right? The square root of 2 is an irrational number. So we could have like plus minus the square root of 2. That would be 2 irrational roots. Okay, let's do an example. So I want us to determine the nature of the roots. That's the directions. Determine the nature of the roots. And the equation is x squared plus 6x minus 16 is equal to 0. Okay, so I'm not asking you to solve. I'm not saying what are the roots. I'm not saying solve for x. I'm just asking you to determine the nature of the roots. What kinds of numbers will these roots be? So we're going to use the discriminant b squared minus 4ac. And we're going to plug in. So I have 6 squared minus 4 times 1 times negative 16. So we're going to have 36 plus 64. Well, do we agree that 100 is greater than 0? Since 100 is greater than 0, we know it's going to be real number roots. But because 100 is a perfect square, not only are they going to be real numbers, they're going to be what kinds of real numbers? Rational numbers. So we're going to have 2 rational roots. And what does that mean, 2 rational roots? Visually. No, rational is not necessarily a whole number. Rational can be a decimal as long as it's terminating, because an irrational number is a decimal that doesn't terminate and doesn't repeat in a pattern. Say it one more time.
Like if it's 2 rational roots, then it's like the root disappears when it's on.
Oh, no, I'm just saying visually on a graph, what does this mean? If I have 2 rational roots, what does that mean on the graph? It hits the graph on the x-axis twice on what kind of number? On a rational number. Okay, let's look into Desmos. Let's see what this looks like. I don't know what the roots are here, but we'll look. So we have y equals, what was I? X squared plus 6x minus 16. Okay, so here's our parabola, right? And we're saying, isn't it the x-axis? Well, what do we have? -8 and 2. Are those rational numbers? Yes, that's all it's telling us. It's just telling us where this parabola is going to cross the x-axis will be a rational number. That's it. What's wrong, guys? What are you looking at? Rihan, I think they're laughing at you. That's not nice, guys. Okay, next one. So our next example will be when the discriminant b squared minus 4ac is equal to 0. This is what I call a double root. Which means we're going to have exactly one solution. And I'll show you what that means, because it sort of goes against everything we said, right? Because we said a quadratic has a degree of 2, but how do we have a degree of 2 and have exactly one solution? We'll look. You guys know. Some of you know. But we'll look to see what that looks like in a minute. But an example of this would be x squared plus 4x plus 4 equals 0. So we're now going to plug in b squared minus 4ac. So we have 4 squared minus 4 times 1 times 4. So we're going to have 16 minus 16. Isn't that 0? So because that discriminant is 0, we're going to have one double root. That's what we would call it, one double root. Well, let's look at when we factor this. If I have x squared plus 4x plus 4 equals 0, and I were to factor this, wouldn't this be x plus 2 quantity squared? Which means x will equal -2, and then x will equal -2 again. So technically, how many solutions do I have written down here? 2, but isn't it the same number? Right, what that looks like, this is why we call it a double root. It's because it's one number counting twice, hence the double root name. This looks like a bounce on a graph. So if I have y equals x squared plus 4x plus 4, if you notice, I'm not actually fully crossing that x-axis. I'm hitting my root, and then what's happening? I'm bouncing back up. So it's not crossing the x-axis to be able to hit it in another location. So when it's a double root, that value counts as the two answers, x minus 2 and then another x minus 2. So it bounces right through, where everything else, if you look at it, that's not a double root. Hits the root, goes down, pops back up to hit another root. Do we see that? Okay. So now we talked about when the discriminant is greater than 0. We talked about when the discriminant is equal to 0. What do you think we're going to talk about now? Less than 0. So our last scenario is going to be when the b squared minus 4ac is less than 0. We're going to have two imaginary roots. So an example would be 3x squared minus 4x plus 3 equals 0. So if we're finding the discriminant, we're negative 4 squared minus 4 times 3 times 3. So we have 16 minus 36, which is a negative 20. Negative 20 is less than 0. So since our discriminant is less than 0, we're going to have two imaginary roots. What do you think that looks like in the graph? Pranav? Yeah, there is. It's not, we're not physically seeing it cross the x-axis. So I'll show you. Y equals 3x squared minus 4x plus, ooh, up in there, plus 3. There we go. Do we see that it's crossing the x-axis at all? No, it's been shifted up. It is, we don't have any real number solutions for x. All right, so now let's do a sample problem of what I might ask you. So I'm going to say find the value of k so that the given equation will have the specified root. And our first one is going to be the equation x squared minus 20x plus k equals 0. And we want to have exactly one solution. Well, if we have exactly one solution, what did I call that? I called that a double root. So we want the discriminant to equal what? 0. So to have exactly one solution, we want discriminant to equal 0. So I need b squared minus 4ac to equal 0. If that happens, I'll have exactly one root. So now I'm going to just plug right into my formula, and we're going to have negative 20 squared minus 4 times 1 times k needs to equal 0. So I have positive 400 equals negative 4k minus 4k equals 0. So we have negative 4k equals negative 400. So k will equal 100. So what does this tell us? This tells us if k is 100, I will have a double root. Let's see what that looks like. So we're going to have y equals x squared minus 20x plus 100. And is that our double root right at 10? Yes. Oh, mesh. Because that root counts twice. So this would be x minus 10 and then another x minus 10. Yes.
These ones, can you just complete it? With data?
On the test, I'll probably ask something where I say, tell me what the discriminant is, and then I will word it so you have to find the discriminant. Okay, next one. So we want to take x squared minus 20x plus k equals 0, but this time I want two imaginary solutions. So if I want two imaginary solutions, what do I need the discriminant to be? Less than 0. So I need b squared minus 4ac to be less than 0. So again, we have negative 20 squared minus 4 times 1 times k to be less than 0. Positive 400 minus 4k is less than 0. Negative 4k is less than negative 400. But when we divide by a negative, what do we have to do to the inequality? Flip it. So we need k is greater than 100. If k is greater than 100, then we will have two imaginary solutions. All right, last problem for today. Anybody still copying this? We're okay? All right, last one. 2x squared plus the quantity of k plus 2 times x plus 8 equals 0. And I want exactly one solution. So exactly one solution, we need the discriminant to equal what? 0. So I need b squared minus 4ac to equal 0. But this is not going to be as straightforward because my b is a binomial. So I have the quantity of k plus 2 squared minus 4 times 2 times 8 to equal 0. What do I have to do with that quantity of k plus 2 squared? Foil it. If we foil this, we're going to get k squared plus 4k plus 4. Is everybody okay that I foiled that in my head? Then if I multiply negative 4 times 2 times 8, I'm going to get a negative 64. So we have k squared plus 4k minus 60 equals 0. Am I trying to factor this right now? Well, yes, yes and no. I'm not trying to factor the original one, but am I trying to factor this k? Yes, because I need to know what value of k will make this have a double root. So we're going to factor this because it's a quadratic. So we're going to get k plus 10 and k minus 6. K will equal negative 10 or k can equal 6. Right? Be very mindful. This is not telling me these are my roots. These are not the roots. What is this telling me? The value of k that will make this have a double root. Does that make sense? So these are not my actual roots. These are just the values for k that could potentially make it have a double root. We good? Yes. Oh, I love that. Yes, you could have. It's not always going to work out that nicely, but in this scenario, it did. All right.